Okay, so today we're going to be talking about section 1.2, which is about observational studies versus designed experiments. Now, unfortunately, we're going to continue our definition dive. So today we're going to be starting off with explanatory variables versus response variables. Now, if you've taken a science class, you've probably heard of independent variable versus dependent variable. Well, that's all an explanatory variable is an independent variable, and a response variable is a dependent variable. Now, if those didn't really make sense in science class, here's how I typically think about it. When you're doing an experiment, what you typically do is you vary the amount of the explanatory variable to measure the effect on the response variable. So typically what you do is you kind of tinker with, or you think that the explanatory variable will somehow cause a change in the response variable. So maybe if I raise the explanatory variable, let's see what happens to that response variable. Or maybe, hey, is the explanatory variable there or not? Does that affect the response variable? So explanatory variable is what I'm starting with to measure what happens to the response variable. Now, in order to start setting up these experiments where we're going to gather stuff and information about the population, it's important that we talk about the differences in types of studies we can do. For instance, an observational study will measure the value of a response variable without attempting to influence the value either of the response variable or the explanatory variable. Now, notice I'm not trying to influence the value. This means I'm not really tinkering with anything. I'm just doing something like, I don't know, hand out a survey, you fill it out to me. I'm not like making changes in your life. This makes observational studies very passive in nature. I'm just kind of seeing what happens without messing around with stuff, without trying to control stuff or change stuff. Now, this is opposed to a designed experiment. A designed experiment is one type of study in which the researcher intentionally messes with things, or they intentionally change the value of the explanatory variable, then record the response in the dependent variable. So if you're doing something like handing out a survey, you fill it out, I'm not messing with your life, that would be an observational study. I'm observing you, not changing you. Whereas if I start, like, say, messing with your diet to see what happens to your weight, that would be a designed experiment because it's very active on my part. I'm tinkering with things. For example, a study is conducted to determine if there is any relationship between brain cancer and the use of cell phones. Doctors ask patients with brain cancer about their use of cell phones. Is it an observational or designed experiment? This would actually be observational. The reason is I'm not doing anything to you to influence you. I'm literally just giving you a survey. Your habits are what they are with that cell phone. This would not be a designed experiment because I'm not doing anything like making you hold your cell phone to your ear, for instance. This is opposed to the next example. Dogs are randomly divided into two groups. One group is trained using food as a reward, while the other is trained using sound cues. After 2 months, each group is taught a new skill to compare obedience. Notice how much tinkering I'm going. I'm separating out the groups. I'm teaching one way, I'm teaching one the other. I'm not like letting them do their own thing. This would absolutely be a designed experiment. Now, sometimes you'll want to dive into the past, or sometimes you'll want to follow people for a long time in your studies. This would be the difference between a retrospective and a prospective study. A retrospective study is one in which only data from the past is used. This might require individuals to look back in time or require the researcher to look at existing records. For instance, if I wanted to know something about have the implementation of seatbelt laws lowered traffic fatalities, well, I don't want to be doing any influencing there, but what I would do is probably look into the past and see what it was like before seatbelt laws were implemented, and then see what happens after they were implemented, all of which would be held in past records. A prospective study, on the other hand, is one in which the data is collected over long periods of time. So maybe you want to study what types of education is best, whether it be, say, hands-on learning. Maybe you compare homeschooling and non-homeschooling, for instance. Well, what you would do if you wanted to figure out if a type of education is good, maybe, is you would start with, say, a kindergarten class. You would then have them grow up in that education system, and you would follow them along their years, maybe comparing them to the standard education setup. The act of you following them from kindergarten to, say, 12th grade makes it very prospective. You're studying them for a long period of time. Other types of observational studies. Now, this is very much broken down by timing, so look for the time piece in each and every one. Well, you could have case control studies. Or excuse me, three major categories. Let's start with cross-sectional. I got ahead of myself. In cross-sectional studies, you're going to collect information about individuals at a very specific point in time or over a very short period of time. When you think of cross-sectional, think short period of time right here, right now. Case control studies, on the other hand, are retrospective studies, meaning they're done using past records, where individuals who have a certain characteristic may be matched with those who do not. A clear example of this would be smokers versus non-smokers. So this is retrospective. We're talking in the past with case control studies. Now, cohort studies will be studies that first identify a group or a cohort of individuals to participate in the study. From then, the cohort is then observed over a long period of time, making them prospective studies. So a cohort study would be like the one I described with kindergartners, where we identify the group, the kindergarten class, and we follow them for a long period of time. As an example, researchers wanted to determine if having a refrigerator in the bedroom is associated with obesity. The researchers administered a questionnaire to 361 12-year-old adolescents. After analyzing the results, the researchers determined that the BMI of the adolescents who had a fridge in the room was significantly higher than that of the adolescents who did not have a refrigerator in the room. First question, and feel free to pause and go back to that slide while you try to answer these. First question, is this a designed experiment or an observational study? Well, since I'm not influencing them, I'm not planting the fridge in their room, for instance, this would actually just be an observational study. We're just seeing what you are doing. We're not influencing you at all, and we're just gathering data very passively. What type of observational study is this? Well, if we go back here, notice the timing of our study first off. It's very instantaneous. Hey, just fill out this survey, send it right back. Takes you a brief moment to do. We're not going into your past, and we're not diving into your future for a long time. Therefore, we'll be dealing with a cross-sectional study. So this will be cross-sectional because we are doing it over a very short period of time. Or actually pretty much instantaneously. And by the way, notice that you could try to make the argument it's case control because, hey, fridge versus non-fridge. Well, the more important thing with these definitions is the timing of it. There could be some gray area in there, but we would say cross-sectional because of the timing of it. You can have elements of one definition bleeding into elements of the other. What is the response variable? What is the explanatory variable? And are they qualitative or quantitative variables? Well, let's start with the explanatory variable. What are we trying to use to explain the thing we'll get a result on? The explanatory variable will be whether or not you have a fridge. So yes or no, do you have a fridge? This leads us to the response variable, which was BMI. We were trying to use the explanatory variable to tell us something about the response variable. Now, in this case, are they qualitative or quantitative? This right here would be qualitative, which I'll shorthand, whereas BMI would in nature be a number. Therefore, it would be quantitative. Last but not least, does having a refrigerator in the bedroom directly cause a higher body mass index? Now, clearly, I've capitalized that word for a reason. Just because we found that there is a link between a fridge in the bedroom and higher BMIs, significantly higher even, does not mean that having a fridge in the room will actually cause you to have a high BMI. For instance, maybe I have a bunch of water bottles in my room. That's 0 calorie. That probably wouldn't necessarily affect my BMI. In fact, it might indicate that I should have a lower one because I'm like healthier by some metric. So just because you have a fridge in the room does not mean you will instantaneously, immediately have a high BMI. This is the difference between correlation and causation. Correlation just means that two things are related in some way. When one goes up, the other goes up. When one goes down, the other goes down. Yeah, that was the case with the fridges. When you had a fridge in the room, BMI was higher. When you didn't, it was lower. They are correlated. It does not necessarily mean that it's caused. This is kind of like arguing innocent until proven guilty in a court of law. Just because you were standing in the room with, say, a murdered body doesn't necessarily mean you are the murderer. That would be an instance where correlation doesn't mean causation. There's still more investigating to be done. As a somewhat humorous, somewhat dark example, here's something that is insanely correlated. The number of people who have drowned by following in a pool, you'll see in red, and films Nicolas Cage appeared in, you will see in black. Notice when one goes up, the other goes up. When one goes down, the other goes down. And they follow each other quite a bit of the way. These are insanely correlated, kind of crazily so. However, they are not causal. It doesn't mean, hey, when Nick Cage appears in a film, great, more people are going to drown. Definitely no causation there. But they are correlated. Now, goofy example aside, you might say, hey, there's probably still a little something to that fridge versus BMI argument. Well, what you would be looking for to try to prove your case would be any confounding that had occurred. Confounding occurs when the effects of two or more explanatory variables are not separated. For instance, are there any variables at play in the background? Maybe we should have said, hey, what's the caloric content of the fridge? Waters have 0 calories, but if you're doing a bunch of Mountain Dew, that might mean something different. Two types of variables that could pop up would be a lurking variable. That's going to be an explanatory variable that was not considered in the study, but that affects the value of the response variable. For instance, the caloric content of your fridge. And another one would be a confounding variable. A confounding variable is an explanatory variable that was considered in the study whose effects cannot be distinguished from a secondary explanatory variable. So sometimes you just have variables that are too interlinked. There's no quite great way of separating them out. For example, possible lurking variables in the previous study could include something like drinking habits. What's the caloric content of your drinks? It could be the amount of exercise per week. We didn't even consider if these kids were active or not. If you're just playing video games versus a marathoner. And more that you could probably name. And just so you know, if you ever see this in a research paper, if the researcher states something along the lines that these results remain significant after adjustment for socioeconomic status, what they're telling you by saying that is that they made an effort to avoid confounding. In this case, the researcher said, well, maybe socioeconomic status could have a role. So what they're saying is that they attempted to rule out socioeconomic status And hey, when they did rule out, the results were still significant. So they avoided confounding as far as socioeconomic status goes. That concludes 1.2, which is all about observational studies versus designed experiments and the variables that you will encounter when doing such. So let me know if you have any questions. Other than that, good luck.